Hi everyone, I'm so excited. This is our very first chemistry video, so I'm going to do something different. I'm going to watch the video with you. But before we begin, you need a piece of paper and a pen or a pencil. So pause the video now if you don't have it with you because you're going to need it in a second. So I'll wait for you. Thanks for getting everything ready. So let's go ahead and watch this video together. So I'm going to push the play button and let's watch.
Hi, welcome. Today's lesson is on physical and chemical properties and physical and chemical changes. These are important concepts in chemistry, so I want to make sure you understand them.
All right, so when you're watching a video at home, you need to take notes. Because it's a video, you can pause it and write down what's on the screen. So if there's any information on the screen, you need to pause it and write that down. So I've pushed the pause button for you, but go ahead and push your pause button also. And make sure you write down the definition of a physical property. I'll wait for you. So push the pause button and come right back.
We'll look at physical properties first. What is a physical property? Well, that's any property of matter which can be perceived, observed, or measured without changing the chemical identity of the substance. So that's a lot of words. What does all that really mean? Well, let's take a look at some examples. Here I have two Petri dishes, one with some ice cubes, here they're a little cold, and one with a strip of magnesium. So what can I observe about them without changing their chemical composition? Well, water is the composition of ice, and magnesium is the composition of this metal. So H2O for the ice and magnesium for the metal. Well, what can I observe about them without changing that fact? Well, I can observe that they both are solids at room temperature. There we have a...
So you might want to put that down as an example. Whether they're a solid, liquid, or gas is a property, a physical property of the material. So let's see if there are any other physical properties.
Solid ice chunk, and the magnesium's a solid. They're both rectangles. They both have a color. The magnesium is a little silver, and I'd say the ice looks a little whitish in color here.
So we also mentioned a couple more physical properties. Did you catch them? There were the shape of the material and the color. So we have state of matter, shape, and color are three different physical properties. So put that in your notes.
So there are many things I could observe about these two materials, and they would be considered physical properties as long as they still were H2O and magnesium. So I want you to go online on the internet and look up some other physical properties, or think of some in your own head, that you could observe while the materials remained their same chemical composition. So that's a physical property. What about a physical change?
Once again, here's some information that you will need. So pause the video and write this down in your notes. Now, you may need to pause it even though I've paused it myself, but pause your video also so that you have time to write this down. And then, when you're done, push the play button again, just like I'm going to do.
Well, that's any change in which the matter's physical appearance, property, or form is altered, but the chemical composition remains the same. So we need a change this time, but not a change in its chemical composition. So what about our two examples? Here we have ice, and you might not be able to see too well with the webcam, but as we've sat here for a while, the ice has actually started to change its form, but not its chemical composition, because it's melting. And so underneath these ice cubes, I have liquid water. But liquid water is still H2O, and the ice is still H2O, and you can kind of see they're kind of floating around because they're floating on water now. So that's a physical change. The water appears different than the ice cubes, but they still are made up of the chemical 2 hydrogen atoms and 1 oxygen atom, H2O.
So once again, you might want to pause the video and write down an example of a physical change is a change in state. So it went from a solid to a liquid, but both were H2O. So that's a physical change. So write that down.
So it looks different as a liquid than it does as a solid. That's considered a physical change. So there we have it. What about the magnesium? Ooh, the ice is really cold too. What about the magnesium? What could I do to the magnesium and change it but still remain magnesium? Well, let's think about that. I could take out a pair of scissors and cut the magnesium into smaller pieces, so I would have changed its appearance. Instead of one long strip of magnesium, I would have several strips of magnesium. So let's actually do that. Have a scissors and I'm cutting the pieces. And now I still have magnesium, but it looks different because I have 4 pieces instead of 1 piece, and each piece is now smaller than the original piece, but it's still all pieces of magnesium.
So you might want to pause it again and write that if you change the shape of the material or the size of the material, that's also a physical change. So after you're done writing that, push the play button again.
So the physical appearance or a physical property has changed, but I haven't changed the chemical identity of the material. I still have magnesium. I may have changed its shape. I'm changed its individual mass of this or the individual volume of each of these, but I didn't change that it's still magnesium. So what I did here was I have a physical change, both with the ice turning into liquid water and the magnesium turning into smaller pieces of magnesium. In both cases, the chemical composition was the same. So what's a chemical property?
Oh, this would be a good time to pause the video again and get out your notes and write this down. So you actually pause it also, and when you're done writing, push the play button again. And I'll be right here.
Well, that's any property that describes the way a sample or matter may change, but this time the change has to alter the chemical composition of the matter. So I need to have a new substance when I'm done. What we observed before, I ended up still with H2O and Mg, still water, still magnesium. So what is a chemical property of water and what is a chemical property of magnesium? Well, I have to be able to describe how it's going to change or react. Well, what could I do to them to get a new substance? Well, I could take the magnesium, and you might know that metals react with acid. So I could react the acid with the metal, and I could get a brand new substance. So what new substances would I get? Well, it would depend on the acid I put in here. If I used hydrochloric acid, I would get magnesium chloride and hydrogen gas. So different substances than what I started with. So that would be a chemical property for magnesium. It reacts with an acid.
So there's an example of a chemical property. Many metals react with acids. So you could put that down as an example of a chemical property. It is telling you how it's going to react.
What about H2O? What's a chemical property of H2O? Well, you may or may not know this, but H2O can react with an electric current, and you can separate the hydrogen from the oxygen and turn it into hydrogen gas and oxygen gas. And we'll actually do this demo later on in the year, and we will do what we call electrolysis. So magnesium reacts with an acid, water reacts with an electric current, and in both cases you get brand new materials. You get hydrogen and oxygen for the H2O, and you get hydrogen gas and magnesium chloride for the magnesium. So
you may want to pause the video again and write that second example of a chemical property. Water decomposes with an electric current. So that's a chemical property of water.
was a chemical property. We described how they reacted, and we got new substances for both descriptions. So if I want to see a chemical property, it has to undergo a chemical change. Because I can't see that this is going to react with acid, the magnesium, unless I actually react it with acid. So what is a chemical change?
So once again, pause your video and make sure you have this definition down in your notes. And then when you're done, push the play button again. And I'll be right here.
A chemical change is any change in which the chemical composition of the material is altered and a new substance is formed. So let's go back to our examples again. Here I have the magnesium, and here I have the water. I'm only going to show the reaction of the magnesium here with the acid. So I'm going to react it with 1 molar hydrochloric acid. I'm going to squirt it on these samples. Oh, watch carefully. I'm going to squirt some more. See if you can see the...
Oh, and anytime there's a little demo and you want to see it again, you can always rewind the video. So let's rewind that and see that again. Let's play that.
So I'm going to react it with 1 molar hydrochloric acid. I'm going to squirt some more. See if you can see the bubbles form. That bubbles represents the hydrogen gas being formed. You can see it right there. You get the hydrogen gas, and it kind of moves around. I'm going to do it a few more times. It's kind of fun. So the chemical composition is changing. It's not magnesium anymore. It's turning into hydrogen gas and magnesium chloride with the addition of hydrogen chloride, which we call hydrochloric acid. So as
I'm going to stop the video right then because I noticed I made a mistake. The magnesium is changing, but you notice you still have some there. If I added enough hydrochloric acid, all the magnesium would disappear and become magnesium chloride and hydrogen gas. So let's continue.
I shake it around. You can kind of see the bubbling that's going around on the edges. That's the formation of the hydrogen gas. So look kind of carefully, and you can see the bubbling right around this piece of magnesium. That is an indication that a gas is being formed. And so we have a chemical reaction or a chemical change because I have new substances that I didn't have before. So instead of just having magnesium, now I have magnesium and hydrochloric acid is going to become magnesium chloride and hydrogen gas.
And in this point in our year, you wouldn't know what they became, but you could see that a reaction was taking place. Later in the year, you'll be able to predict what kind of products are going to be formed for each reaction.
There's an example of a chemical change going on. So, what are the evidences? How do I know that a chemical change actually occurred? How do I see that a new substance is being formed? Well, here are some clues, or what we call evidence of a chemical change. And so
Wow, that's a lot down. So you may want to pause the video. Here, I'm going to rewind it a little first so that it's on the screen.
Actually occurred. How do I see that a new substance is being formed? Well, here...
All right, there. You can pause it on the screen, and you pause it also, and then write down this list of evidence of a chemical change. And when you've got it down, push the play button again. I'll still be here.
Some clues, or what we call evidence of a chemical change. And so we can have results that are not conclusive. So because you get bubbling sometimes, that doesn't mean you always have a chemical change. You can boil water and you can see bubbling, and that's not a chemical change because you just are making water vapor. So these are clues, but you need a little more information sometimes. So what are the clues? Well, you can have a change in odor. So if you get a new smell, that's a clue. So we will have chemical reactions in class where all of a sudden, oh, it smells like ammonia or something, and you know you have a new chemical. You can get an unexpected color change. What do I mean by unexpected? Well, if you take two clear solutions, you would expect it to become clear. But if it turns yellow, that's unexpected. What's not an unexpected color change? Well, that's if you take blue and red and it becomes purple. That's expected. You should know that from art. So it has to do something that is unexpected color change. You can also have a change in temperature or energy. So if the material is getting hot and you're not putting it on a hot plate, or it's getting cool and you didn't put it in the refrigerator, or it gives off light, it's doing something unusual, that's another clue that a chemical change might be taking place. You can also have the formation of a gas, which we just did with our last reaction. That bubbling we saw was the hydrogen gas being formed. And the last clue here that we have listed is the formation of a precipitate, which is kind of a long word that means solid particles. And you can see that because the solution may become cloudy, or you can actually see chunks. So if you mix some transparent solutions together and it becomes cloudy, or you can see chunks, you've made a solid, and that's a new material. So there we have it, some clues for chemical change. So we have physical properties, physical changes, and chemical changes. So hope you enjoyed this lesson. Thanks for listening.
Hey, that was fun. I got to watch the video with you. I won't do that every time, but I just wanted to show you that you can pause, fast forward, or rewind a video, and so that you can have all the information that you need. Hope you enjoyed it. I enjoyed watching it with you. See you in class.